Hello, this is Miss Moore, and today during chemistry we're going to discuss atoms. Specifically, we're going to talk about the subatomic particles. Today's essential question: what are the subatomic particles and where are they located? All right, let's get started. Atoms. All matter, everything, is made up of teeny particles called atoms. Okay? And when I talk about all matter, I mean pretty much anything you can think about except for heat and light. Okay, so you are made up of atoms, desks, tables, the floor, the ceiling, all made up of atoms. The air you breathe, all made up of atoms. So again, all matter is made up of tiny particles called atoms. And atoms have two different regions, the nucleus and the electron cloud. So I'm going to draw a really ugly picture of a nucleus and electron cloud. So this little tiny dot right there, that little red dot, represents the nucleus. And we'll talk about this more later, but you'll notice it's really, really small and really, really dense. It's all solid. Okay, and then we have, so that there, I guess I should, this is the nucleus. Oops, sorry. Okay, and then, how about, right, but then we have the electron cloud. The electron cloud is like a cloud, kind of puffy, you can kind of see through it, and it surrounds the nucleus. So this is my wonderful representation of the electron cloud. Okay, so that is the electron cloud. You'll notice it's big, way, way, way bigger than the nucleus, and truthfully, I didn't draw this to scale at all. The electron cloud is actually even bigger compared to the nucleus in what I drew, and I didn't make it solid. You can sort of see through it. It's like a cloud, thus the name electron cloud. Okay, so the atom is made up of two different regions again, the nucleus, which I drew somewhat in the center, and the electron cloud, which surrounds. All right, we're going to come back and visit the nucleus and the electron cloud a little bit later, but for now, let's move on to the subatomic particles. So, atoms are made up of smaller particles. We call these the subatomic particles. So it's the particles, sub means below. So below the level of the atom, we have these particles, subatomic particles. And they are protons, neutrons, and electrons. So the atom is made up of 3 subatomic particles. Make sure you know this term, subatomic particles. And those subatomic particles are protons, neutrons, and electrons. So let's spend a little bit of time talking about each of these subatomic particles. So we'll start with the protons. Protons are found in the nucleus. And protons have a positive charge. So protons are positive. Protons have a positive charge. They are positive. So we often don't write out the whole word protons. We'll symbolize it. And we symbolize it by a P for protons, and then a superscript of a plus for positives. All right, next up is protons are very large. Now, to be honest, protons are not large at all. They're actually really, really tiny. We can't even see them with the naked eye. But when I talk about a proton being large, I'm talking about a proton, the size of the proton compared to the 3 subatomic particles, protons, neutrons, and electrons. So protons are really large when we talk about comparing them to the size of an electron. Okay, in fact, the mass, or you can think a mass, we're sort of thinking about how much something weighs. It weighs about 200 times more than an electron. Okay, and the actual mass of a proton is 1 AMU. AMU, we'll get back to this later, but an AMU, I'll jot it down. Let's see, I'll move this a little bit. AMU stands for atomic mass unit. So AMU stands for atomic mass unit. So now we have relatively large positive protons found in the nucleus. Oh, I like that. So we have large positive protons in the nucleus. Okay? So next, let's talk about the neutrons. Neutrons are also found in the nucleus. Neutrons have no charge, so they are neutral. Neutrons have no charge, so they are neutral. Okay? And just like the protons, we also symbolize neutrons. Neutrons are N for neutrons and 0 as a superscript showing no charge. Neutrons are also pretty large, again, compared to the other subatomic particles, compared to the size of the electrons. Okay, in fact, they're basically the same size as a neutron, as a protons. They are also 1 AMU, which is 200 times the mass of an electron. All right, so we have large neutral neutrons in the nucleus. So we have large positive protons in the nucleus and large neutral neutrons in the nucleus. All right, we've talked about protons and neutrons, so let's talk about the third and final subatomic particle, which is the electron. So, electrons. Electrons are the only subatomic particle type that is not found in the nucleus. Electrons are found outside the nucleus in a region called the Electron Cloud. The Electron Cloud can also be called orbitals. And we'll talk more about a little bit about orbitals this unit, but mostly we'll talk about it next unit. Okay, so electrons are found outside the nucleus, the only subatomic particle found outside the nucleus, and it's found in the electron cloud. Electrons are negatively charged, okay, and they're symbolized by a lowercase e with a superscript of a negative. Electrons are very, very small. I mean, all three subatomic particles are very small, but if you remember, if we just compare them to each other, the electrons are like 200 times smaller than a proton or neutron. Okay, so a lot smaller. In fact, what we say about the mass of an electron is we say that they basically have no mass. Okay. Now, do they have a mass? Of course they have a mass. But because they're so small, their mass is so insignificant that we can basically ignore it. So, example. Let's say I pick up a feather. Do you think a feather has a mass? I mean, can you feel it? Yeah, it definitely does have a mass. However, what if I got on a scale and weighed myself and then picked up a feather and got back on the scale? Do you think my weight would change? Probably not. Why? Because the feather is so much lighter than me that the scale won't even notice it. Okay, so it's the same sort of thing with an electron. Okay, the electron is so much smaller than a proton or a neutron that it basically has no mass. So we're going to talk about it like it has no mass. All right, so let's see. We have very small negative electrons in the electron cloud. All right, so quick review. We have 3 subatomic particles. First one, large positive protons in the nucleus. Second, we have large neutral neutrons in the nucleus. And third, we have small negative electrons found in the electron cloud. So that's it for the 3 subatomic particles. So now let's talk about the 2 regions of an atom. So the nucleus, this first region of the atom. The nucleus is small compared to the size of the atom as a whole. So it takes up very little of the volume of an atom. In the volume, the definition of a volume is the amount of space something takes up. In this case, the amount of space, I'll just leave it at that. Something takes up. Okay, so the nucleus is really small compared to the size of an atom as a whole. So it takes up very little of the volume of an atom. So let me go back to that beautiful picture I drew at the beginning. Here it is. Here's the nucleus here, and in red, you'll notice that it's really tiny, whereas, let's see, if that thing circled in yellow is the whole atom, with the nucleus being the red and the electron cloud being the gray, you'll notice that the nucleus takes up way less space than the electron cloud. So the nucleus is really small compared to the size of the atom as a whole, so it takes up little of the volume of the atom. Remember which subatomic particles are in the atom. We have the protons and the neutrons. And remember that the protons and the neutrons were both pretty big, right? And they're in the really small nucleus, which means they're smushed in there. They're densely packed. They're really smushed in there. So the nucleus is very dense. And I'm going to go back real quick to that really beautiful drawing. And you'll note that I colored it in really darkly, right? I didn't show any really empty space. That's because all those protons and neutrons are squished in there tight. Okay? All right. So the nucleus is small and it's dense. And because protons and neutrons have a great big mass, the nucleus makes up most of the atom's mass. So we have a small, dense, heavy nucleus. Okay, so it's small, it's dense, and it's very heavy. This is kind of interesting. The nucleus itself also has a charge. It has a positive charge. Well, why? Because it contains positively charged protons, which will give it a positive charge, and then it contains neutrons, which have no charge. So if you put something positive with something neutral, you end up with positive. Okay, so let's re-summarize our nucleus. A nucleus is large, dense, heavy, and positive. And that would be our nucleus. So we have a large, dense, heavy, positive nucleus. And on to the very last topic for today, and that would be the second region of the atom, which is the, shout it out, electron cloud. Okay. The electron cloud, or orbits, surrounds the nucleus. Okay, so in my beautiful drawing, it was that gray part, and we'll go back to it in a minute. The electron cloud is much, much bigger than the nucleus, which means the electron cloud makes up most of the atom's volume. And since electrons are in the electron clouds, and electrons have very little mass, so the electron cloud makes up very little of the atom's mass. So I'm going to go back, I'm going to scroll up for a minute and go back to that beautiful drawing. Okay. So if you look at the gray squiggles representing the electron cloud, you'll notice it's way, way bigger. And there's a lot of empty space. You can kind of see through it, right? That's why it's really light, as well as the fact that there are electrons in there. It's not dense at all. The electrons are not packed in there at all, but it's huge. So it's big and light. Okay. And do you think the electron cloud has a charge? Think about what's in the electron cloud. Okay. The electron cloud has a negative charge. Why? It contains electrons, and electrons have a negative charge. All right, so our electron cloud what are our review key terms for an electron cloud? It's large, light, meaning not weighing very much, and negative. All right. So, quick review. Let's go over what we've learned. See if you know it. Protons. What do we know about protons? Protons are. Let's find our protons again. Protons are large. Those are neutrons. Miss Moore, let's try that again. Right there. Protons are large, positive, and in the nucleus. Neutrons are large, neutral, and in the nucleus. Electrons are small, negative, and in the cloud, the electron cloud. So Protons, large positive nucleus. Neutrons, large neutral nucleus. Electrons, small negative electron cloud. Then we have, let's talk about the nucleus. Nucleus is small, dense, and heavy. And the electron cloud is, oops, I forgot something on the on the nucleus. It's large, dense, heavy, and positive. Sorry about that. And why do I have large, people? Small. You should have told me a long time ago. Somebody shout that out, Hope. The nucleus is small. Small, dense, heavy, and positive. And lastly, the electron cloud is large, light, and negative. All right, folks, that's it for today. Have a good one.